All right, hi everyone. What we're going to do today is we're going to be finding values to given z-score, or finding values given the probability or given the percentage. So we're going to do this in three phases. The first thing we're going to do is find the z that corresponds to the probability. Then we're going to find the x value given the z, and then we're going to put it all together into a problem. Okay, so when we're finding a z-score given the area or the probability, okay, we want to, key to this is to making sure that the area is to the left of the z-score. So in other words, if it says left or bottom or right, or left, bottom, cumulative, we're just going to read our charts. If it says right or top, we're going to have to do some other things. All right, so let's try a problem. So we want to find the z-score that corresponds to the cumulative area of 0.3632. So we're going to draw our picture that corresponds to this. Okay, so here's my normal curve. Remember, 0 is in the center. And remember that 0 is half, so 0.5 is to the left and to the right. So 0.3632 would be to the left of that. And that is going to be the shaded region. So 0.3632. Okay, so we're interested in what is that z-score that corresponds to that. So we need our z-chart that corresponds to this. So let's go get our z-chart. Okay, and I was doing some work earlier. Sorry about that. All right, so what we're going to want to find is 0.3632. So that's somewhere over here. Oh, there it is. It's purple. It's already highlighted. Okay, so I'm going to follow this over to the left, which is negative 0.3, and I'm going to follow this up to find the hundredths place. So it looks like negative 0.35. So that is the z-score that corresponds to that. Okay. All right, so let's try the next one. We want to find the z-score that corresponds 10.75% to the right. Okay, so we're going to draw our picture. Okay, here's 0. And again, 50% would be to the right and to the left. If I want 10.75%, it's going to be up here somewhere. Think of it as like the top 10%. So I'm going to change that to a decimal, 0.1075. Now, since it's to the right and my z-chart is only cumulative from the number to the left, we're going to have to figure out this part. So we're going to have to do 1 minus 0.1075. And when we do that, we get 0.8925. And that is the shaded region to the left. And that's what we're going to look up in our z-chart. Okay, so 0.89725. Oh, there it is. 8925. Let's make that darker. Here it is. Okay, so I'm going to go up. It's 0.04. If I go left, it's 1.2. So my z is 1.24. Okay, so let's try another one. All right, so we want a positive z-score for which 95% of the distribution lies between two of them, negative z and positive z. So let's draw our picture. Here we are. So 95% of our probability or data, whatever way you want to think of it, is between these two values. Now, if you remember when we did this last time and we want to be between, we subtracted the two values that we got off our chart. So what we're going to need to do here is look at the extreme areas. Okay, so these two sections right here. So I basically need to find that guy. because again, we're looking to the left. So if I can find that guy, I can look him up in the chart. So if 95% is in between, and the whole thing is equal to 1, we can find that these two pink shaded regions together is 0.05. And since there's two of them, let's divide it in half. 0.025. That's what I'm going to look up in the chart. Now I'm going to use the negative because that's the easiest one to find, but we're going to be able to find, because once we find the negative, we also have the positive. We just have to drop the negative sign. So 0.025 on the negative side. Okay, so let's erase that. So 0.025. Oh, there it is. Okay. And again, if I go left, I have negative 1.9, and I go up, it's 0.06. So negative 1.96. And that's the negative z. So z, the negative z is negative 1.96, and the positive z would be positive 1.96, since it's exactly the same on both sides. All right, so let me know, make sure you can read the chart. So we're going to do the same thing as we're given a percentile. So the key here is to change your percentile to a percent. So this percentile is 5%, 5. So that means it's 5%, which we're going to change it to 0.05. Now again, percentile means from that number to the left, below, how much percentage of the data is below that. So we have 5% of the data, so we're going to want to find the z-score that corresponds to that. Okay, so 5%, 0.05, so we're going to be looking for 0.05 in our chart. All right, oh, there they are, there it is. Now, unfortunately, 0.05 is exactly in between 0.0495 and 0.0505. Now, since it's exactly in between, okay, you have a choice, 1.965, 1.65, and 1.64. But I'm going to split the difference. Because it is exactly in the middle, we can make our z 1.964 or 1.645. So this is going to be negative 1.645. Okay, and we can only put that 5 there at the end if it's exactly in between the two numbers. Otherwise, pick the one that's closest. Okay, 50%, which is 0.5. What did we say? 0 is 50%, so my z here is 0. I don't even have to look that up. Okay, 90%, so this is 90%, so 0.90. And again, percentile is always to the left, so I don't need to do any minus ones or anything along that, one minuses or anything along that lines. So I got to find 0.9. Let's get rid of whatever this is. 0.90, 0.32. Okay, so again, it's not exactly in our table. So it's between 0.8997 and 0.9015. I'm going to choose 0.8997, mainly because that number is closer to 0.9 than 0.9015. All right, so that puts me at 1.28. So that's going to be the z I'm going to use. Okay. All right, so now that we've been able to read the chart and given the probabilities of the percents, we're able to find the z. Let's take it to the next step. We have a formula, which is just a variation of your z-score formula, to find the x value. So all we're going to do is we're going to put the z, the mean, and the standard deviation into this formula and figure out our x value. So here, our mean is 9 and our standard deviation is 2. So we're going to have x equals 9 plus 1.96, which is our z, times 2. Okay, when we do the math, we're going to get 12.92. And these are pounds because that's how much our cat weighs. Okay, so this cat is 12.92 pounds. This one, our z is negative 0.44. So we're going to do x equals 9 plus negative 0.44 times 2. Okay, I get 8.12 pounds. Okay, so our cat is smaller than the average, which makes sense because the z-score is negative, which means it's below the mean. Here our z is 0. So right away we know that that means it's going to be the average, which is 9 pounds. Now if you didn't recognize that, we could do x equals 9 plus 0 times 2, which is just 9. Okay. So now we're going to take this process and the process with finding z, given the probabilities find the z, into one problem. Okay. So your z, if it's left, less, cumulative, or bottom, all we're going to do is read the chart. If the question says right, above, top, we're going to do 1 minus the percentage, and then we're going to look it up in the chart. And if it says between, we're going to do that 1 minus. So please don't forget to change your percents to decimals. So 1 minus that, we're going to divide it in half because there's 2 sections. And then we're going to look it up in the chart. We're going to get a negative value. If we want the positive, we're going to want the top. We're going to want take the positive value. Right? And then we're going to use the x equals mu plus z omega formula. Okay, so here we have the California Police Officer Standards and Training Test are normally distributed with a mean of 50 and a standard deviation of 10. The agency will only hire applicants scoring in the top 10%. What is the lowest score you can earn and still be eligible to be hired by the agency? Okay, so we want the top 10%. Okay, so let's draw our picture that goes with that. Okay, here's our normal curve. Since I want the top 10%, it means this section is 0.10. And we want the z that corresponds with that. Now, since we're in the top, we have to, again, our chart goes from the number to the left. We have to do 1 minus because this is the area that our chart goes to. So this is going to be 1 minus 0.10 or 0.9. So again, we're going to look up 0.9 in our chart, which we have. We did that earlier. So 1.28. Okay, so our z is positive 1.28. Now we're going to take our z and use the formula. So x equals our mean, which is 50, plus 1.28 times 10, which is our standard deviation. Okay. And we get a value of 62.8. So you would need a score of 62.8, okay, to be hired to be eligible to be hired by the agency. All right, let's try one more. All right, randomly selective sample of women ages 20 to 34. And the mean cholesterol total level is 179 milligrams per deciliter with a standard deviation of 38.9 milligrams per deciliter. Assuming that cholesterol levels are normally distributed, find the highest cholesterol level a woman in the age group of 20 to 34 can have and still be in the bottom 1%. Okay, so since it says bottom, let's draw our picture. Okay, so here this says bottom 1%. That means this section to the left, 1%, keep in mind it's 0.01. We're going to have a negative z value that's going to correspond to that. So we're going to look for 0.01 in our chart. So I'm going to pack up here, find 0.01. Okay, as close to 0.01 as we can get. 0.0099 or 1. I'm going to go with 0.90019. This one is pretty close. There's not much difference. So I'm going to choose this one. So negative 2.33. So that's going to be the z that I'm going to use. Negative 2.33. Okay, now again, we're going to use our formula. So x equals our mean, which is 179, plus negative 2.33 times the 38.9 standard deviation. We do the math, we're going to get 88.363. So the highest cholesterol level that you can have and still be in the bottom 1% is 88.363 milligrams per deciliter. All right, let me know if you have any questions, guys. Remember, to stay in means we're going to stay safe.